So what is this radio about? So this radio, I actually got my hands of it about 5 years back, where I used to fly with the local flying club. So they said that this radio is faulty. What do you want to do with it? So they just gave it to me. So the first thing I did was like, okay, let's tear down and see what's inside. Okay, so a brief history about this radio. So this radio is made by this company called Kheng Radio. First released in 1969. Also, it's many decades already. Then after that, in 1985, Kheng Radio merged with Bendix. So they call themselves BendixKing. Then after that, in 1999, Honeywell acquired BendixKing. So Honeywell is probably a name that we are more familiar with. So this radio has it supports 3 different functions: two-way voice communication in this frequency range, navigation signals, as well as glide slope signals. Then everything operates at amplitude AM signals. Okay, so this is what the radio looks like on the outside. So the interesting thing you can see here that this radio is made in Singapore. Nice. Yeah, it's very rare to have an electronic product made in Singapore already. Then at the back of this radio, we can see these cut edge protectors. So this is where it will interface with the rest of the aircraft. So there are 3 BNC antenna connectors for the 3 different functions: communication, navigation, and glide. So connect to 3 different antennas. Okay, so this is the drawing. This way. Okay, so this is the drawing from the maintenance manual. It details how do you install it. So this radio requires another adapter here. Okay, then the rest of the aircraft is connected to this adapter here. So the reason is that it's to facilitate easy replacement. So when you want to replace this radio, right, you just need to pull this one out. You don't need to really disconnect everything behind. Okay, so how does a pilot use this radio? Okay, so this radio, you can see there are 2 LCD panels. The one on the left is to display the communication, the voice communication frequency. The other one is the navigation frequency. Okay, so for this communication frequency, right, the way to set it is actually to turn this knob here. You rotate this knob, then it will adjust the standby frequency. Okay, then after this frequency is set, then whenever the pilot wants to use this frequency, the pilot will press this COM frequency transfer button, and then these 2 frequencies will swap. So the standby becomes the use current frequency, and the current frequency becomes the standby. Okay, so this is a bit theoretical, so I'll show you how I actually use the radio. Okay, let me go to 60. Okay, so let me. Okay, so we note this timestamp. So at the start of this video, this is me. I'm flying the aircraft. Then beside me is my friend who's also a pilot. So at this point, right, I'm on the ground. I want to request to the ground controller that I want to switch frequency to the tower. Okay, then shortly after that, I'll actually switch to the tower frequency. Okay.
November 5748 Echo, switching to tower.
November 5748 Echo.
Okay, so after that, I press the transfer button, switch over. Then now I'm tuning the other frequency, which is the approach controller after that.
11845, primary frequency. Okay, 127.7.
Oh.
Okay, 11845, 127.7. It's dim, but
yeah.
level.
127.7.
Okay. Seletar Tower, November 5748 Echo at Echo 1, ready for departure to area Alpha.
November 5748 Echo, speed to tower, good afternoon, line up runway 21.
Line up runway 21, November 5748 Echo.
Okay, so let me go to the next part. So the next part of the video, right, I'm actually in the air. So now I want to switch from the tower to the Paya Lebar approach. Basically, it's the approach controller, another ATC in charge.
5748 Echo, switching to Paya Lebar approach.
So now I will press the COM transfer button to bring the standby to the use.
Paya Lebar approach, November 5748 Echo, entering area Alpha.
November 5748 Echo, Paya Lebar approach, good afternoon, and no reported traffic in area Alpha, QNH 1007.
November 5748 Echo, QNH 1007, no traffic in area Alpha. Establish area Alpha now.
November 8 Echo, copy.
Okay, so to power the radio, right, it supports both 27.5 volt or 14 volt operation, but for this particular one unit is 27.5 volt. So we need to connect like that lah. This I connect to my power supply unit just to try. So like this, and then apparently we need to connect these two pins as well. Okay, so let's go through then also the first thing when I open this radio, yeah, this is what I see. So they can see mostly through hole components, and the traces are right angle. It's not really good practice these days. We at least we know you should at least do a diagonal angle, right? But this one, everything you can see is right angle.
Actually, the other way around.
It should be
that practice, and now it doesn't really matter.
yeah. Okay, I'm not very certain. It's a signal reflection.
Better you have like
Yeah.
not high frequency.
Okay. I think I opened the Pandora's box here.
So you understand why it's very.
No.
The other side of the coin is that it used to be that practice because of the way they made PCBs. If you have a right angle, then the action can sit in that little corner for longer than normal, and it'll just eat through your trace at that point. So it used to be bad because of that reason. Nowadays the processes are a lot better and they don't care.
Okay. Okay, then for the analog RF section is at the top now. So as you can see, it's shielded. Okay, so the processing unit, the first thing I went to see what is this CPU. It's some old CPU. When I try to Google, I cannot find any documentation on it. Zero. So this is the only information I can find from the maintenance manual.
Is it dedicated for this purpose? No, it was manufacturers were using
Yeah.
a bunch of others that do the same thing. So it's mask ROM. You know what I mean? It's a mask ROM.
Sorry?
It's a mask ROM,
Mask ROM.
meaning that the program is in the ROM.
Oh, okay.
It's put there before the one was going. Yeah, permanent.
I'm not certain. I'm not sure.
It's really common that a chip manufacturer would contract to a device manufacturer to say, we'll make a lot of CPUs and we will include your firmware.
It looks like this is a 2K ROM. Yeah, it looks like. But I have no documentation on it, so I cannot be certain. Yeah. Yeah, for the frequency. Okay, so the plasma gas display, right? Yeah, this is actually what it looks like at night. It's visible, more visible at night. Yeah. But the problem with this radio is that there are no spare parts now. So whenever these displays fail, right, this radio is just, it cannot be repaired easily. So there are some hacks with using LED displays. Okay, then I went to check. So based on the data sheet, it says that these particular chips here, they are the high voltage cathode decoder drivers for the plasma gas display. Okay, so one chip here controls one digit at a time. Okay, then I call it the MCU. The MCU will sense this BCD input to this chip here to decide which segment to display.
BCD.
Huh? Yeah, they say they are based on the data sheet. BCD, yeah. Okay, but then how can one driver control many different digits, right? It's because okay, this one particular only connect to the cathode, but the common anode, right? The anode side, right, is actually controlled by another chip. Then after that, they use the clock transition to split between all the digits. Yeah. Yeah, something. Yeah. Then after that, okay. Then on the back side of the radio, right? So we can see that there's metal shield cans here. Yeah, these are all the analog part. To further isolate, I believe to further isolate this section now. Okay, so for the transmit concept, okay, I'm not an RF person, so based on what I read on the documentations, so this is a process. So when the pilot pushes the PTT, so the transmit receive switch is set to transmit mode. So there's actually something like a relay, right? So it will, depending on where it's being set, you move to the transmit section or the receive section. Then the CPU will tune this voltage control oscillator to the correct carrier frequency. Then you take the signal from the microphone audio to modulate the carrier frequency. Then it's sent through a series of amplifiers. So I identified the amplifiers here. Okay, so the transmit receive switch is here. Yeah, they go through the pre-driver, the driver, and the final amplifier. Okay, so as for the receive section, okay, so the receive section, this is architecture diagram. It's quite blur. It's taken directly from the manual. So based on what I see here, so I understand yes, the input signal is filtered first. Then after that, right, there's a mixer here. They will take this receive frequency from the voltage control oscillator to shift it to an intermediate frequency, to an 11.4 megahertz intermediate frequency via heterodizing. So after heterodizing, we will get two frequencies. One is the sum and one is the difference. Okay. So after that, this thing is passed over to the bandpass filter, which is 8-pole, which is low impedance to 11.4 megahertz. So only 11.4 megahertz go through. Then after that, there's two stages of amplification. So to boost this signal up. Okay, so this you can see from this is 8-pole crystal ladder. So this is a picture I took for Wikipedia. So it's a very sharp bandpass filter, low impedance to the desired frequency, which in this case is 11.4 megahertz, and some capacitors to tune the bandwidth. And you can see the date code here is 1986. Yeah, very old radio. Okay, so yeah, this is the end. So the radio is quite complicated. And what impressed me a lot is that these were designed in the 1960s. So the IC chips that this radio used must be quite modern at that time in 1960s. Okay. So my last question that I did thought of is like how modern avionics system look like if this was like 50 years ago, more than 50 years ago. Today, what is the technology like? I don't know lah. Yeah.
It's not as dense.
Yeah, everything is
Exactly. Put an FPGA there and cut it. Maybe a few property blocks if they're feeling generous.
Okay, yeah, so yeah, that's all. Yeah.
So for everything you feel that is new this, right?
Yeah.
And it has some like but it also suddenly connects to the rest of the airplanes. So
Yes.
what is that for? Because this functionality doesn't really interface with the controls of the airplane.
Okay, let me see. Let me see. I mean, there's some part, definitely is the push to talk button. And
What about the navigation stuff?
navigation is just a pure antenna.
What's feeding it? Like,
What does it do?
Okay, the navigation is connects to the VOR station.
Which gives it's a circuit,
Yeah, the
right?
VOR is it gives you I think the two axes from the station.
To answer the question, there's an output on that edge connector
yeah,
that is connected to the
display.
display to the UI.
Yes. Yeah, correct. The glide
What-
slope is also instrument landing system.
Yeah,
The other one.
so we can get a couple other bits. And
Okay, maybe do I have the picture of that? Okay.
Yeah.
Yeah, this is clearer. So the VOR at the iOS is or this part.
So we receive the signal and based on that update that.
Yes, yeah.
And how does it do both parallelly? I guess different frequencies. So
Yeah,
you can
parallelly,
adjust
yes.
it.
Why is it
Have
useful?
Yeah, multiple antennas.
Why is it useful to have the changeover button from blind scope? I get why you have it for voice. Why do you have two frequencies and a changeover button for blind scope?
It could be my guess is that different runways, right? If let's say you suddenly switch to a different runway, you want to tune it, but you don't want to affect the current frequency. It gives you a way to see the frequency.
Is there something where you have two glide scopes on the same runway?
No, two parallel runways.
But normally one runway only have one.
Yeah, one only, one frequency. You can't have two on the same.
If you're setting up an approach, you wouldn't normally line up both.
Yeah.
No, so it's one is standby. So it's you want to tune the other one without affecting your current one. Then you finish tuning, then you say,
But is it something you do typically when you?
okay, this is only used by instrument rated pilots. I've not used this, but I only understand the concept only.
Okay.
Yeah. So you have multiple, you have two frequencies.
I guess it's also so that it can make you distinct inputs and swap that to what it was.
Well, that makes sense for voice,
Yeah.
but it makes less sense for light scopes. Because you don't.
What is it like scope?
Okay. I will give when aircraft lands, right, there is a certain slope which is typically about 3 degrees. So this glide slope frequency is to communicate with the system to, for example, this, right? It tell you how high or how low you are in respect to the slope.
Basically to help you target that.
Yeah, 3 degrees. Because you do more, you too sharp, you too low, you might you might hit the ground too fast.
Is it only for landing?
Yeah, correct. It's called instrument landing system. Only for landing.
The visual equipment is often, you did that job.
Yeah.
If you had a visual landing. Isn't that? Can't we see the lights for visual landing?
Sorry?
Yeah.
From here, from a non-instrument landing.
Yeah.
Oh, you mean here?
Yeah, it knows. So they do the same.
Yeah, this is called the puppy indicator. So the puppy only works for visual.
Yeah, correct.
So
So the glide scope does the same thing, but for instrument lens.
because it's Roman, you outside you cannot see anything. It's cloudy or maybe yeah.